In the last section, we figured out how to make sure that we only receive a number of messages equal to the number of requests that we make. I now want to make one little change to our program. So I'm going to add in one additional requirement or one additional feature. I want to say that we're not going to ping each of these websites just one time. I want to say that I want to continually ping each site repeatedly over and over and over again. Every single time we make a request, so let's say that we make one to google.com, whenever this routine finishes up, I want to then immediately kick off another routine that attempts to fetch Google again. And so this is going to make our program function a little bit more like a status checker probably would, where we are constantly making requests over and over and over again until we finally say, oh, it looks like there's an error here. Maybe this website is down at this point. So let's figure out what we're going to change inside of our program to make that happen. So essentially, we want to say that anytime a request completes, we then are going to immediately start one right back up. And so chances are it's going to have to do something with this for loop right here that we had previously put together, because this is the line of code or the block of code right here that essentially is handling whenever a request gets completed. So here's what we're going to do. We're going to say that whenever the check link function is completed, rather than returning, or I should say pushing this simple string into the channel, or this fixed string right here, let's say that whenever we finish the request, we take our link, which is also a string, and push that into the channel. Then, back inside this for loop right here, we can receive that link through the channel. Whenever we receive the link through the channel, that means that the previous routine must have just finished, and we should start up another Go routine that again attempts to call fetch link with a given link. Or check link with a given link, excuse me. Okay, so let's give it a shot. The first thing we're going to do is find both of the statements where we push a value into our channel. Rather than pushing in these fixed strings, I'm going to say that we're going to push our link into the channel. So remember, we are receiving link as an argument, and this is the URL or the actual address that we are making the request to. So we're also going to replace it down here as well. Okay, so now once we finish the request, we then either log out, hey, this website is down or it's up, and then we take that link and push it into our channel. So now, back inside the for loop we were just working on, we need to fix up this code right here to make sure that whenever we receive this value, we then kick off another check link Go routine. So I'm going to replace the format.println statement right here with a call to check link. And we're going to call check link with the value that comes out of the channel. And so we are saying that we want to receive a value from the channel, which means that we're going to place an arrow and then the channel name, like so. Okay, so remember, this receive of the value or the receiving of a value through the channel is a blocking operation. And so we're going to just kind of sit around and wait until we get a value in here, and then we'll immediately call check link with it. Now the last thing we have to do is make sure that we call check link and create a Go routine with it. And so to do that, we're going to make sure that we put the Go keyword right in front of it. Okay, now just one last step, one last thing we have to do. At present, this for loop is only going to run like the 5 or 6 times, essentially the number of times that we have, or however many strings we have in that slice of type string. But I'm saying that I want to make sure that we just continually fetch links from now through eternity. So just through all time, as long as this program is running, I want to make sure that we always go and try to fetch some additional link. So to make sure that we just loop for eternity inside this for loop, we can condense the syntax inside this thing to be simply for and then the opening curly brace. So this right here is an infinite loop. It's never going to exit. It's never going to get away from this. So anytime we put a value into our channel, we will then spawn the new Go routine with the check link function. The for loop will then progress on to the next iteration, where it's then going to again wait for another value through the channel. And so even though this is an infinite loop, it's not going to be getting called like a million times per second. Like this for loop is not going to be executing again and again and again, like just over and over and over again, many times per second. This receiving of a value through the channel is still a blocking operation. And so the for loop is only ever going to progress through itself, or it's only ever going to loop anytime that we actually receive a value through the channel, which might be like, at best maybe 5 times a second, assuming that we're fetching these HTTP, or we are completing these HTTP requests very quickly. Okay, so let's save this and now see what happens. Now, when I save the file, you're going to see a little bit of an error here. My mistake, I did not pass in the channel as a second argument. So remember, it expects us to receive the channel as a second argument. So we'll make sure that we put a comma after that and then place the channel like so. So now let's save it, and it compiles successfully. And so this is actually kind of interesting right here. Notice how check link expects to see a string as the first argument. And so Go is able to say very intelligently, oh, this looks like a channel that's going to produce a string, and so we will allow this as the first argument. Even though clearly, like you and I look at this, and gee, it sure doesn't look like a string to me, but Go knows that this is going to eventually produce a string. And so it's allowed to be the first argument, matching up with the type string that we expect to see. Okay, so let's run this code and now see what happens. So I'll flip back over to my terminal. And I've got a couple of messages in there, so we'll do go run main.go. And now we start to fetch our links, and you can see very quickly we are fetching all these different addresses again and again and again very, very quickly. So at this point in time, there should only ever really be 5 requests active at any point. Okay, so this code is definitely working, but I think that you can agree with me that we probably do not need to ping each of these websites quite so quickly. So maybe the last thing we need to do here is make sure that in between every successful fetch, we should put a little bit of a very small pause in here so that these different websites don't think that we are trying to just flood them with requests. So maybe we'll say that we'll put just some arbitrary space of time in between each request. So let's figure out how to tackle that in the next section.